Alright, so let's discuss ellipses. So to discuss an ellipse, let's start with an example. You always want your equation of an ellipse to be in this format. So it should be x minus h bracket squared over a squared plus y minus 3 bracket squared over b squared equals 1. This will allow you to graph an ellipse easily because we can locate the center. The center here will be -2 and the y coordinate would be 3. So x coordinate of the center is -2, y coordinate is 3. So our center is -2, 3. Square root of 64, which is 8. You're going to go 8 to the left from the center and 8 to the right from the center. Square root 25, which is 5. You'll go 5 up and 5 down. So that's how you graph an ellipse. There are other interesting parts of an ellipse that you may want to know. So 64 is bigger than 25. So our horizontal axis here is called the major axis, and it's of length from 8 and 8, 16. Our vertical axis here is called the minor axis, and in this case it is 5 plus 5, 10 long. Okay, so these points that you see here, when you go from the center 8 to the left, so you're going to have the x coordinate -2 minus 8, which will give you -10, and the y coordinate will remain 3. If you go to the right, you have -2 plus square root 64, which is 8, which will give you 6, and y coordinate will remain 3. The other vertices are, if you go straight up, 5, and so that will give you -2, 8. You're changing the y coordinate, and if you go down, you will subtract the 5 from the y coordinate of the center. So these 4 points are called vertices of an ellipse. If you look at the square root of absolute value a squared minus b squared, a square is this number, b square is that number. Taking the square root of absolute value 64 minus 25, which is square root 39, is going to allow us to locate the foci for an ellipse. And so our foci are -2 plus square root 39, 3 is the y coordinate, -2 minus square root 39, and 3 is the y coordinate. So that -2 minus square root 39 and 3, that's this coordinate right there. -2 plus square root 39 and 3 is right there. So those are your foci. And an interesting reflective property of ellipses is this. If an energy source is originating at one of the foci, it will bounce right off and go to the other foci. And it doesn't really matter where it goes. It will bounce right off and go to the second foci. You may have seen this concept demonstrated if you go to Wisconsin Dells, the Robot World. They have something called Whispering Gallery, where you stand on a couple of footsteps, you whisper, and somebody in the other room standing on the other 2 footsteps will hear you. And that's because you have a shape like this in front of you. You're standing here, you're whispering. It'll bounce off the wall here and go to the other person standing on the other footsteps, even though they're in the other room. You can see this in whispering galleries. They have sometimes shapes of rooms that are ellipsoids, where if you're standing here, no matter how crowded the room is, you can whisper and it will go up and bounce right there. There is an application of this concept to cure kidney stones. They have a machine that uses this principle. For extra credit, find out what the name of this machine is and the basic principle on how it operates. All right, let's take a look at hyperbola. Similar shape, you can see. So you will graph it the following. So center is 2, 3. Square root of 9 is 3, so you'll go left 3, right 3, and then up 2 and down 2. And that allows you to get the diagonal. So here's how it would look. So you go left 3, right 3, up 2, down 2, and connect. Make a rectangle, and the diagonals of this rectangle are your asymptotes, and then your vertices are on the side here, you can see. And so you're going to go 2 plus square root 9, and 3, 5, 3 will be one of the vertices, and 2 minus square root 9, 3, which will give you negative 1, 3, which will be your other vertex for a hyperbola. This hyperbola is going left-right because this negative sign is with the y coordinate. If the negative sign was with the x coordinate, it will go up and down, but similar shape. So what is the equation of these asymptotes that we see? The asymptotes we see, you can see the slope of these lines, because remember, slope of a line is rise over run. And so our rise was given by this, and our run is given by the square root of this. So square root of 4 is 2, and square root of 9 is 3. So 2/3 is our slope. So 2/3 times x minus 2 equals y minus 3 is one of the asymptotes, and negative 2/3 would be the second slope, and that would be your second asymptote. So that's how you find asymptotes. So the slope is always b over a. To find the foci, you have to find the c, which is taking the a squared and the b squared, adding them together, taking the square root, which will give you square root 13 in this case. And so 2 plus square root 13 comma 3 is your first foci, and 2 minus square root 13, 3 will be your second foci. All right, let's take a look at this hyperbola. Again, center will be 2, 3. A is 3 because of square root 9, and B is 2, which is square root of 4. This minus sign is located with the x, so we know the hyperbola is going to be facing up and down. So again, to graph, you're going to go 3 to the left and 3 to the right, 2 up and 2 down. You can make your box so you can draw your asymptotes, and then these will be your vertices, and there's your graph for hyperbola. All right, let's take some examples and you decide. So pause the video here and you do these problems, and then we'll check and see if you got them right. Assuming you have paused and come back. So first, anytime you want to identify a conic section, and look, we have a y squared and an x squared term, which means it's either going to be a circle, an ellipse, or hyperbola. So get all the terms on one side, number on the other side. In this case, the equation will look like this because you're adding x squared and subtracting 2x. And then complete squares like we've been doing before. So here, x squared minus 2x, you're going to have to take half of negative 2 is negative 1. Negative 1 squared is 1. So if you add 1 on the left side, you have to do it on the right side. There's only one y squared term, so it's already a complete square. And so our equation is going to look like this. So it's already in the right format. So circle center is going to be 1, 0, and the radius is square root 1, which is 1. So our equation is a circle. And then to graph it, here's your center 1, 0. You're going to go 1 to the left, 1 to the right, 1 up, 1 down, and then you sketch the graph. All right, let's take a look at second example. Again, see if you can pause the video, do it on your own, and then you can check whether you got it right. Assuming you have paused and come back. So again, we have only one square term, and the y is not a square term, so you know it's going to be some form of a parabola. And so we get it in the right format for a parabola. And so again, complete square. So first we have to write negative x squared plus 2x, pull out the negative 1, complete the square, again add 1. But remember, you're really adding negative 1 times 1, so you're subtracting a 1, which means you'll have to subtract 1 from the other side, factor the 4 out, and you get it in the right format. 4p is this negative 4, so p is negative 1, which means our parabola is going to be facing down, And our vertex is going to be x coordinate is 1, y coordinate is 1/4. Since p is -1 and we're going down, the y coordinate will be 1/4 minus 1. Let's take a look at this one last example. So pause the video, do it on your own, and then come back and check if you got it right. Assuming you have paused, let's take a look. So we take the equation, we have the same techniques that we've been using. You complete the squares, and so look, you have a negative x squared term and a positive y squared term, so you immediately know it's going to be an hyperbola. So pull out the -4 from the x terms, pull out the 9 from the y terms. Half of 4 is 2, 2 squared is 4. But you're really adding -4 times 4, which is -16. So you have to do that on the other side. 9 times 1 is 9, so add 9 to other side. And now complete the squares. Remember, we need 1 on this side, so divide everything by 36. Now we have it in the right format. So we know it's a hyperbola. -2, -1 will be our center. And you're going to go left, right, 3, and up, down, 2. So we have hyperbola, and there is our picture. So -2, -1 is our center. This hyperbola is going up, down. So you're going to go up 2 and down 2. Left 3 and right 3. Complete the box. Get your asymptotes, and there's your shape.